Hey class, let's get on to class B. So in class B, we're going to do a couple things. We're going to talk about how to find the slope between 2 points. We'll do that first. The other thing we're going to do is to talk about how to find the equation of a line, either when you're given a point and a slope, or when you're given 2 points. Yeah, that's pretty much it. So let's get to the examples and to the kind of formulas, I should say. Move stuff around here. Yeah, got a lot of stuff on my small desk here. So let's look at this first example. We want to find the slope between the points 2, 1 and points 5, 4. So we're going to draw these, although you don't. So I will point out first and foremost, you don't ever have to actually draw this unless you're asked to. You're just trying to find the slope with a very numeric calculation. But let's draw it so we can kind of see what's happening. So from the point 2, 1 to the point 5, 4, 2, 3, 4, 5, 1, 2, 3, 4. So that is the, well, those are the points that I'm trying to find the slope between. I guess I can draw the line segment between those 2 points. If I draw that, it looks like this. And what I'm really kind of focusing on is the slope is what often referred to as the rise over the run. So I think about from here to here, and really what I like to do is I kind of like to drop a perpendicular here, or really just draw the right triangle. And think about how the fact that, well, from this point to this point, the rise is 3. And from this point to this point, the run is also 3. So if you look at this, without doing any calculating yet, we can see that the rise is 3, the run is 3, and the rise divided by the run is going to be 3 over 3, which is 1. Now, if we start like plugging in some points, we can say, well, this here is the point 5, 4. This here is the point 2, 1. This here, by the way, is the point, well, it's the same height as 2, 1, so it's got the same y coordinate. And it's the same right or leftness from the origin. So it's got the same x coordinate as 5, 4. So that's point 5, 1. And oh yeah, from here to here, you're just going 3 up. From there to there, you're just going 3 over. So the slope is 1. Now, the way we calculate this without drawing any of these pictures is we say, well, the slope, which we often use the letter m for, is going to be the difference in the y's, 4 minus 1, the rise, over the difference in the x's, 5 minus 2, which is going to be 3 divided by 3, which is 1. I will also point out, it doesn't actually matter which order we subtract things in as long as we're consistent, meaning I did these y, this y minus that y, and the same x minus that x, right? Essentially, if I think of this as x2 and y2, this is x1 and y1, I did y2 minus y1 over x2 minus x1. But I also could have done it the opposite order, 1 minus 4 over 2 minus 5, and gotten the same thing. So either way you want to slice it, you can get the slope equation without drawing any of this picture, just by subtracting the y's on top and the x's on the bottom, as long as you're doing these ones minus these ones, or these ones minus these ones. It would be incorrect to say the slope was going to be 4 minus 1 over 2 minus 5. I can't do that y minus that y, but that x minus that x. I have to keep the order the same. And it's not that, because that would be 3 over negative 3, which is negative 1. Definitely the slope is positive, not negative. All right, let's look at some more examples. So let's find the slope between these 2 points, negative 4, 5, and 4, 1. So this time, let's find the slope first, and then we'll draw it later to see the rise or the run thing. So I'm going to think of this coordinate as x1, y1. This coordinate as x2, y2. And the slope equation, and people like to write this lots of ways. You can think of it as the rise over the run. You can think of it as the change in y, which we call delta y, over the change in x, called delta x. But the formula you actually want to remember is the difference in the y's over the difference in the x's. You can totally write it that way, or if you prefer, it is equally correct to say it is y1 minus y2 over x1 minus x2. Either way will get us there. In this example, I'm going to say that my slope is going to be, let's see, so 1 minus 5, always the y is on top, over 4 minus negative 4. 1 minus 5 is negative 4. 4 minus negative 4 is really 4 plus 4, which is 8. So I get negative 4 over 8, which reduces to negative 1/2. Let's plot the point and see it. So let's say I've got the point negative 4, 5, so 4 left, 5 up, and 4 comma 1, 4 right and 1 up. And so when I graph this, again, my graphing, sorry, I'm turning things around here, but it's what I've got. Sorry, there we go. So if you look at here, from here, as I move right, every time I go over 2, I go down 1, right? Over 2, down 1, over 2, down 1, over 2, down 1, over 2, down 1. So my rise is negative 1. In fact, let's draw it one time here. So from here to here, I have a rise of negative 1. I have a run of positive 2. We always kind of think of the run as being positive because we're moving from left to right. The rise, on the other hand, is going to be negative if we're going down from left to right, or positive if we're going up from left to right. Let's look at some more examples. This one got kind of messed up here. So let's find the slope between, in fact, you should try this one on your own before I do it. Find the slope between negative 4, negative 2, and 2, negative 4. So, okay, I'm just going to throw the equation at it. I'm going to switch it up this time and do it the opposite way. So I'm always, whichever one's written first, doesn't actually matter. I'm going to call this one x1, y1, and this one x2, y2. You could totally interchange the names, doesn't matter. This time I'm going to calculate the slope as y1 minus y2 over x1 minus x2. Doesn't matter, right? As long as you're consistent. So that's going to be negative 2 minus negative 4 divided by negative 4 minus 2. Be careful with those negatives, right? You gotta be able to, so when you do minus and negative, it's really plus. So negative 2 plus 4 over negative 4 minus 2. Negative 4 minus 2 is going to be more negative, so it's going to be negative 6. Negative 2 plus 4 is negative 2 plus 4 is 2 over negative 6. That's going to be, I don't want to write 1 over negative 3. It's kind of considered unsimplified. I should put the negative out in front and write it as negative 1/3. So when I go from left to right, every time I go over a run of 3, I'm going to be going down a rise of negative 1. So let's see, let's plot the points. Negative 4, negative 2, and then positive 2, negative 4. I'll try and draw the graph without turning everything around this time. Let's see here. This ruler is kind of weird. It's kind of, but it's fine. So there's my, and yeah, we can see every time we go over 3, we go down 1, over 3, down 1. And you can keep doing that. All right, let's do a couple more because there's a couple special cases that we want to look at. Let's see here. So I want to find the slope between negative 1/5 and 3/5. So let's just calculate it. And I'm not, you don't have to label these as long as you're careful, right? If I just think if I'm doing these ones minus these ones, then my slope is going to be, let's see, y minus y, so 5 minus 5, and 3 minus negative 1. So that's going to be 0 divided by 4, and 0 divided by any non-zero number is just 0. Right? If you want to think about that for a second, you're asking yourself, how many times does 4 go into 0? Let's see, 4 goes into 0 times, and 0 times 4 is 0, and you subtract, and the remainder is 0, and that works out just fine. So check. Graphically, what does it mean that our slope is 0? Well, it means we have 0 rise for whatever amount of run we have. If I plot these points at negative 1/5 and at positive 3/5, we see that we actually just get a line that doesn't slope upwards or downwards. slope is just I should say the line is just that horizontal line. The slope is 0, the line is horizontal. I will mention here, because it seems like impossible not to say it, the equation of this line is just y equal to 5. X can be anything. So it's kind of weird. Like if I said find the y-intercept, you'd say, well, if I plug in x equals 0, there's nowhere to plug in x equals 0. You're going to get y equals 5. And the y-intercept is 0,5. Kind of neat, kind of weird. Let's look at another strange example in the same sort of way. Find the slope between 4, 2 and 4, -3. So when I do this, things are going to get unfortunate. So my slope is going to be, again, it's the difference in the y's. So -3 minus 2 over the difference in the x's, which is 4 minus 4. And again, I'm doing this one minus that one, so that one minus that one. But now I'm going to get -5 divided by 0. And when you divide by 0, that's undefined. 0 gets into 5 or -5 as many times as you want. Let me actually, I don't love the negative here, which is fine. But I just want to point out, if you were to do 5 divided by 0, just ignoring the negative sign for a moment, 0 gets into 5 a lot of times, like as many times as you want. Like I could say 999 times, and let's see, 999 times 0 is 0. Subtract 5 minus 0 is 5. Oh, I could have done more. I could have done right as much as I want forever and ever and ever, because really there's no end, right? 0 goes into 5 an infinite number of times and still doesn't get there. So this -5 divided by 0 is undefined. So specifically for a line like this, and let's actually graph it before I say anything more. I plot the point 4, 2 and the point over 4 down 3. We notice that both those coordinates have the same x coordinate. So the line is going to be a vertical line going through those 2 points. Going through those 2 points. As good as it gets. That line has as much rise as you want over 0 run. And just like literally the slope is undefined, we say the slope is undefined. There is no other way to say it. And that's always going to be the case exactly when we have a vertical line. And never any other time, right? Any other type of straight line, the slope will always be defined. Okay, I think that pretty much covers how to find slope. Let me reiterate one more time. I think that kind of is saying the same thing over and over again. But I just want to point out that if you're trying to finding the slope between 2 points, x1, y1, and x2, y2, you can either get the slope is equal to y2 minus y1 over x2 minus x1, or equivalently, right, it's still just as good, you can do the slope is going to be y1 minus y2 over x1 minus x2. Both of these will produce the same result. This one might look different at first because it'll be like a negative. Well, like if these are both positive, these will be negative, but the negatives will cancel out. Anyway, I think that's all I want to say about slope. Yeah. So the next thing I want to talk about is finding the equation of a line. So finding the equation of a line. And let's see, I think I had something already set up for this. Let me double check here. Yeah. So let's say we want to find the equation of a line, let's say passing through the point 1, 2 with a slope of m equal to 3/4. You don't have to write m equals, it's just kind of a habit of mine. So how do I want to say this? Yeah. So let's look at this graph here. So here's the graph of the line. And when we talk about the equation of a line, what we really mean is that for this, the equation describes the line because any point on the line satisfies the equation. So for example, this point here, this point here is the point 1, 2. And for any other point on the line, this point here, which I could call x, y, or this point over here, or this point over here, no matter what point I pick, the slope between that point and that point has to be equal to 3/4 because they're on the same line. So we're just going to exploit that a little bit. We're going to say, well, we know that the slope between these 2 points, that's going to equal y minus 2 over x minus 1. But we were told that the slope is 3/4, and it is 3/4, right? If you start from here and you go right over 4, you end up going up 3. And now what I'm going to do is I'm going to take this equation and I'm going to multiply both sides by the denominator, x minus 1. So I'm going to rewrite this as y minus 2 over x minus 1 times x minus 1 equal to 3/4 times x minus 1. The x minus 1's cancel, and we're left with what is often called the point slope form. Y minus 2 equals 3/4 times x minus 1. This is where we often start. So I will say, let me go back to this previous page here. I was going to number my pages. I totally forgot what number my pages. Sorry, not this page here. I've lost my pages, right? My pages are all over the place. Oh, well, I'll just write it down here. So what I was saying was that, what was I saying? In general, if you want to find the equation of the line with slope m and passing through the point x1, y1, then what we say is, well, the point slope form is going to be exactly y minus the y coordinate equal to m times x minus the x coordinate. Because it's exactly coming from the fact that y minus y1 divided by x minus x1 is going to be equal to the slope. The problem with this is that we don't usually like to leave it like this. I'd much rather isolate y. And let's grab another piece of paper. Sorry, I got a little disorganized over here. Let me grab some paper. Sure, there we go. So still working on this problem here. What we're going to do is we're going to say, oh, was the piece of paper, the piece of paper was literally the piece of paper behind. Let's go back. I found it. It was hiding under the other piece of paper. So let me focus this a little bit here. There we go. So if I'm going to do this, I'm going to say, well, y minus 2, the y coordinate, is equal to 3/4 times x minus 1. And then I can just isolate y. So first I'm going to distribute the 3/4. So I'm going to get y minus 2 equal to 3/4 x minus 3/4. And I'm going to add 2 to both sides. I'm going to get y equal to 3/4 x. Negative 3/4 plus 2 is really negative 3/4 plus, I'm going to get a common denominator. 2 is the same as 8/4. And then negative 3 plus 8 is 5. So this ends up becoming y equals 3/4 x plus 5/4. That's generally my preferred way of finding the equation of the line in the point slope form. The y equals, the slope intercept form, or the y equals mx plus b form, is by starting with the point slope form and solving for y. Other people prefer to do this. They like to start with y equals mx plus b, plug in the point that they have, and then solve for b. So subtracting 3/4, 2 minus 3/4 equals b, but 2 is really 8/4, and 8/4 minus 3/4 equal to b means that b is equal to 5/4. Same thing we got over here. The only thing I don't prefer about doing it this way, you can totally do it this way, like it's totally fine. It's great to do it this way. I just don't like it personally, because then I have to go back and be like, oh, to finish the process, I actually have to rewrite and say then y equals 3/4 x plus and plug in the b value, which I find annoying, but other people are just perfectly fine with. So that's kind of the idea of finding the equation of the line given a point and a slope. You can either start with the point slope form and work down to the y equals mx plus b form, or you can start with the y equals mx plus b form, plug in your point, and then solve for b. Let's do a couple more examples just to kind of make sure we're good with that. But I think that's, yeah. I'll make sure, like, yeah, we looked at this, that looked fine. Yeah, we had that, and then that became y equals 3/4 x plus 5/4, which looks about right, because if you look at this, right, it certainly looks like that our y-intercept is about 5/4. I will point out for these problems and the stuff we're doing in section B here, we're kind of graphing things without finding the x and the y-intercept. I know that's kind of counter what I said before, but go with it. So let's do a few more problems like this. Let's say I want to find the equation of the line with slope m equal to -2/3 passing through the point, let's go 6,5. Okay, so I'm going to show it both ways. First way, point slope. And then really we're just starting with point slope. We're still going to end up with slope intercept. Y minus 5 equals -2/3 times x minus 6. Distribute the slope. Y minus 5 equals -2/3 x. -2/3 times -6 is really -2/3 times -6/1. Multiply top times top, bottom times bottom, and 12/3 is 4. Plus 4. And now we add 5 to both sides, and y equals -2/3 x plus 5 plus 4, which is 9. Sorry about that. Or start with slope intercept. Y equals m, which is -2/3 times x plus b. Plug in your point. Plug in y equals 5. And it's always weird, like I see the 6 first, I want to plug in the 6, but the y value is 5. So we plug in the 5 equals -2/3 times 6 plus b. -2/3 times -6 was +4. So -2/3 times +6 is -4. So 5 equals -4 plus b, and then add 4 to both sides, 9 equals b. And then we plug that back in up here and we say, okay, y equals -2/3 x plus 9. Same result. And it should always be the same with it, whichever way you do it. I'm gonna grab my drink of water here. So the other thing we do, if we're not, sometimes we're not given the slope. So sometimes someone might say, well, I'm not going to give you all that easy information. I'm going to say, find the equation of the line. Okay, I should stop writing that out. Passing through the points, plural, 1, 4, and -2, 3. So to find the equation of any line, we need a point, which we have an abundance of, and a slope, which we need to find. So we're going to find the slope. So m is equal to 3 minus 4 over -2 minus 1, which is -1 divided by -3, which is +1/3. Great. Now you can go either way you want, and I'll just switch back and forth. I'll do one way, one the other way. So let's do this one the way I prefer. So we're going to do y minus pick your poison, whichever one you like, it doesn't matter. So y, well, it matters a little bit, like it specifically matters which x one you pick. So I'm gonna leave this blank for a second, equals my slope 1/3 times x minus, neither of those are really better, right? If one of them happened to be a multiple of 3, then 1/3 times it would be easy. But since neither of them are, I'm just going to pick the one where they're both positive. So y minus 4 is going to equal 1/3 times x minus 1. It doesn't matter which point you pick, in that you will always get the same result either way, as long as the work is correct. So y minus 4 equals 1/3 x minus 1/3. Y equals 1/3 x minus 1/3 plus 4, but 4 is equal to 12/3, right? 4/1 times 3/3 is 12/3. And I need a common denominator to be able to add these fractions together. -1 plus 12 is 11, so -1/3 plus 12/3 is 11/3. So y equals 1/3 x plus 11/3. I will mention, if you pick the other point, you would get the same answer. If I did y minus 3 equal to 1/3 times x minus minus 2, but let's not write minus minus 2. Let's just write plus 2. You get y minus 3 equal to 1/3 x plus 2/3. And when I add 3 to both sides, 3 is equal to 9/3 if you multiply by 3/3. And 9/3 plus 2/3 is exactly 11/3. So I get the same answer no matter which point I happen to pick to put in. Let's do a couple more. Actually, let's look at a couple weird ones, and then we'll do a couple more normal ones. So there's two kind of weird situations which correspond to having a vertical line or a horizontal line. So for example, if I said, find the equation of the line through the points, let's just say the first one will be -3, 4 and 2, 4. So if I was gonna if I didn't notice right away that the y coordinates were the same, I would just go about my way and be like, okay, well, my slope is going to be 4 minus 4 over 2 minus -3, which is 0/5, which is 0. And then if I kept going, right, if I still was like, well, I'm just going to do what I usually do, I could either do, well, let's do y equals mx plus b. So I do y equals 0x plus b, and then I plug in either one of these points, I'm going to get 4 for y equals 0 times 2 plus b. But 0 times 2 is 0, so 4 equals b. So I end up getting, plugging this back in, y equals 0 times x plus 4. But 0 times x is 0, so I really just get the equation y equal to 4. Which you should get when the y coordinates are the same. When the y coordinates are the same, the line passing through them is just y equal to that value. If we'd gone the other way, right, if I'd gone, I said I wasn't going to do it the other way, so I'll just do, it's fine. So if I do it the other way real quick, y minus the y coordinate equals the slope times x minus the x coordinate. But 0 times anything is 0. So y minus 4 equals 0, so y equals 4. The same kind of thing is true for the x ones, but the x ones are actually kind of weirder. So same question, but now the points are going to be, let's make it -3, 1 and -3, 5. So I find the slope. This is where I think the process actually falls apart, because the slope is going to be undefined, right? The slope is going to be 5 minus 1 over -3 minus -3. And -3 plus 3 is 0. So you get 4 over 0, which is undefined, which just makes us sad. So here we just say, well, slope's undefined. And then you can't use either form, right? You can't say, we cannot do, so no, not this. We can't be like, y minus 5 equals undefined times x minus -3. It just doesn't make any sense. So instead, we have to really use our kind of common sense and say, well, look, I know the x coordinate's the same in both of these points, so I have to have a vertical line. That's also the case when I have an undefined slope. So I know that my equation is just going to be x equal to -3. let's see, how much, I've got about 30 minutes, so I should probably try to wrap it up here. Let's do one more example and then we will call it a day. So one more example, let's find once again, the equation of the line. Let me just say it right, equation. Find the equation of the line through the points -5, -3, and 7, comma, I don't know. 1 seems not fun. Sure, 7, comma 1. Let's just do it that way. All right, so step 1, find the slope. So the slope is going to be, let's see, 1 minus -3 over 7 minus -5, which ends up being 1 plus 3 over 7 plus 5, which is 4 over 12, which is 1/3. Great. So now let's do it all the ways just so that we can see it. So you can either do it y equals mx plus b. So I'm going to do y equals 1/3 x plus b. Pick either point. In fact, let's pick both points. So if I pick 7, 1, then I'm going to have 1 equal to 1/3 times 7 plus b. So 1 equals 7/3 plus b. 1 minus 7/3 equals b, but 1 is really 3/3. So 3/3 minus 7/3 equals b. So -4/3 is equal to b. And then our equation is y equal to 1/3 x minus 4/3. Let's do the point slope version of it, but using the other point. So if I was doing point slope, I would say, okay, well, y minus the y coordinate, but instead of using 7, 1, apologies, I'm going to use -3, -5. So y minus -3 equals 1/3 times x minus -5. I know I said let's not do a minus, but here I am. So then I've got y plus 3 equals 1/3 times x plus 1/3 times 5 is 5/3. Solving for y equals 1/3 x plus 5/3 minus 3. Well, 3 is equal to 9/3, so it's minus 9/3, and then 5 minus 9 is -4. So y is exactly equal to 1/3 x minus 4/3. So in summary, we've talked about how to find the slope between 2 points, as you've seen here many times, and also how to find the equation of a line, whether you have 2 points on the line or the slope and the point. All right, I will see you in class on Tuesday, where we'll go over this stuff, which will be my birthday, 8/8. Anyway, hope you guys found this illuminating, and I will see you later. Bye.